Okay. And the way we can find it on our own is sort of, it's actually very similar to what you did. We're going to have these different paths here. And then if we go down this path, and so we don't stop, then we have an expected win of 3.5.
Yep,
right?
3.5.
Right. So so sort of starting at the end, we know on this branch going down this way, I have an expected win of 3.5. Mm-hmm. So what does that tell me about when should I stop? When should I decide to stop?
Oh, if you are going to get an expected value higher than 3.5.
Okay, and so what's that going to mean?
So 4 or higher.
Right. So we say here, if I go down this path, if I don't stop, I know I'm getting 3.5. So I may as well stop.
If you have the
greater than or equal to 4.
Get more than that.
And now from this, I can go backwards to the beginning and say, okay, what does it look like going down this path now?
So now you're getting an expected value of 4, so you want to try to get more than that. And so...
Well, we should be careful because the expected values, we get, so...
Well, at least.
So on this one, it looks like I'm going to stop if I'm greater than or equal to 4, so that means half the time, if I go up here, what's my expected value?
You get 5.
5, yeah. So I either get a 4 or 5 or 6 with equal probability. So half the time I'm going to get a 5. And then if I go down here, which is also half the time, I get 3.5.
Yep.
So 7 halves. So I get 5 halves, or let's say 10 fourths, just to get a common denominator.
10 fourths times
plus
7
fourths.
So just a little bit more than 4.
Okay, so right, so this is just slightly greater than 4. So now going down this path, I have 4.25 is my expected value if I go down that path, which tells me that at the beginning
you want to get more. So, and the way to have a higher expected value is to stop at 5 or higher.
Right, so stop at 5 or 6. So now my expected value for the whole situation, since I'm now stopping a third of the time here, so it's 1/3 times 5.5.
Yeah.
1/3 times 11 halves, plus 2/3, and this was 17 fourths.
So you could say.
So this is 11/6, which is 22 twelfths.
You can.
Oh, sorry, yeah, you're right. Plus
17/6.
6, so that's
28 over
28/6, which is
14/3, which is what we found in the program.
14/3, yeah, which is what you found in your program. So this was so if we sort of go to it's hard as you saw, but you did actually do all the work. If you start from the beginning and go forward, you get a really massive equation, but you were able to deal with that, which is really cool. If you start at the end and work backwards, it does kind of simplify the problem a little bit in this case. So sometimes that happens. It doesn't happen all the time, but sometimes it happens. And in this case, it did. So that's how we can see that we really can't do better than that.
Yeah.
So because when we work backwards, all of our decisions were sort of
fall into place.
Yeah, they just were very natural decisions. So good. Hey, great job. This was a fun problem. And next weekend we have another problem from Pascal that we'll take a look at.
All right.
All right. Good job.